Get ready for mind-blowing science. Imagine Flash, the fastest superhero around, zooming past a photon's incredible journey from the sun to Earth at a blistering speed of over 300,000 km per second. But here's the thing. No matter how fast we've engineered our spacecraft, we're still stuck in the slow lane compared to light. A photon takes just 8 minutes to make this epic trip. So, why can't we catch up and travel faster than light? Let's dive into some seriously cool science and explore what makes it so impossible for us to reach light speed, and maybe even discover a way to break free from this cosmic limit in the future. You're thinking, wait a minute, isn't there a way around Einstein's speed limit? Well, let's see. His special theory of relativity does indeed claim that nothing can move faster than light. But just like how life always finds a way in sci-fi movies, nature has some pretty wild exceptions up its sleeve. Take entangled particles, for example. These cosmic twins are linked in such a deep way that no matter the distance between them, they stay connected through an invisible umbilical cord. It's as if they're sharing a secret language only they understand. Could this phenomenon give us a hint on how to break free from the speed of light barrier? Let's unravel the mysteries of entanglement and see if we can uncover any clues for faster than light travel. Whoa, hold on to your seat. Here comes the mind-blowing part. When one entangled particle gets a makeover, its partner instantly knows and changes right along with it, no matter how far apart they are. Yep, you heard that right. Faster than light speed information is shared between these cosmic buddies. Einstein himself wasn't too thrilled about this phenomenon since it seemed to challenge his theory of relativity. But the catch here is that entanglement isn't exactly a particle teleportation. Instead, it's more like an instant info update about the particle's state. Now, let's talk wormholes. Could these cosmic shortcuts through space-time potentially be used for faster than light travel? Buckle up and join us as we dive into the wildest possibilities of interstellar exploration. Get ready for some seriously sci-fi stuff. Imagine a wormhole as a cosmic shortcut through space-time, kind of like a secret tunnel or a map with a neat fold in it. Let's put this theoretical wormhole to the test. What if its entrance is right here on Earth, and the exit is just a stone's throw away near our star, the Sun? If something were to zip from point A to point B through that wormhole in a flash, it'd be like hitting the cosmic fast lane, 500 times faster than light speed. However, hold up because things get complicated. Buckle up and let's dive into the challenges of making this mind-bending journey a reality. Buckle up because things just got wild. Physicists warn us that wormholes aren't as cool as they sound. If you dare to travel through them, you'd soak up a massive, potentially lethal dose of radiation. And don't even think about getting too curious. Sticking your hand in there would trigger an explosion so powerful, it'd outshine a supernova, sending shockwaves throughout the cosmos. Now, before you think all explosions are bad news, let's talk about the cosmic fireworks show that happens when two neutron stars collide. These mind-blowing events unleash gamma-ray bursts, unleashing intense energy across space. These gamma-ray bursts are truly awe-inspiring. Their radiation waves inside plasma jets blast through space at mind-bending speeds. You might think we've stumbled upon a way to break the cosmic speed limit, but hold on to your seatbelts, because here's the catch. Hey, those photons are still traveling slower than light in a vacuum. In fact, they're moving at about 3/4 of the speed of light, which is already incredibly fast. But get this, even this blistering pace drops down to just 1/4 of the speed of light when these high-energy waves pass through other environments, like space with matter in it. So, as cool as these bursts are, they still can't outrun the universe's ultimate speed limit. But here's the twist. Those super speedy plasma jets we see during gamma-ray bursts aren't even moving at the speed of light in a vacuum. They're ripping through space at incredible velocities, but they're still bound by that universal speed limit. So, while their radiation waves zoom ahead, they're still about 5,000 cameras per second slower than that magic number, 300,000 kilometers per second. Don't worry, scientists are working hard to crack the code of cosmic speed limits and push our understanding further. The universe has a way of keeping us on our toes. You're wondering how scientists are tackling this cosmic speed limit. Well, they've come up with some mind-blowing ideas. One of them involves building a kind of space-time subway system. Yes, you read that right. Imagine creating tubes or tunnels through warped space-time that could potentially connect two distant points. This idea is actually based on the concept of wormholes, but without the explosive radiation and cosmic chaos. It's like trying to build your own DIY wormhole at home, minus the risk of intergalactic mayhem. Just imagine zipping across our world map in the blink of an eye. Sounds too good to be true. But if we could pull off this space-time shortcut, it's theoretically possible. Now, the bad news, we're still stuck on building that interdimensional auger and can't quite reach light speed with our tunnel paver. Beauty, all hope isn't lost. Enter physicist Miguel Alcubierre, who had a groundbreaking idea while watching none other than Star Trek in 1994 talk about inspiration from the cosmos. You know how in Star Trek, the Enterprise breaks free from Earth's gravity by warping spacetime. Well, it's not just a far-out idea. There's some serious science behind that warp drive. Think about it, we've seen galaxies hurtling away from us at speeds faster than light. But here's the mind-blowing part. They're not actually moving through space any faster. Instead, the space between them is stretching out and expanding at a pace that Einstein's laws can't keep up with. That's some seriously cosmic expansion happening right before our eyes. You might know Miguel Alcubierre from his mind-bending concept, the Alcubierre warp drive. It's like a cosmic surfboard ride. Imagine being able to harness space itself to propel your ship forward. Here's how it works. You'd create a kind of space bubble around your spacecraft, where space-time in front of the ship is compacted and behind it is expanded. This would generate a pressure wave that allows for faster-than-light travel without actually moving at light speed. It's like riding a gravity wave to break all the speed records. Now, here's where things get really interesting. Or rather, really challenging. The Alcubierre warp drive relies on something called negative energy. But don't worry, I'm not talking about the emotional kind you feel when your crush walks by with someone new. Negative energy in this context is a hypothetical form of energy that scientists are still searching for proof of. If we could find it and harness it, though, we might just have the key to making warp drives possible. But until then, it's purely a mind-bending what-if scenario. The million-dollar question: can we finally shatter the cosmic speed limit and zoom past light's pace? Sounds amazing, but hold on, because there are some major hurdles to overcome. So, let's dive into them. As you push closer to that magical speed of light, Einstein's theory of relativity starts throwing some serious roadblocks your way. Buckle up, because the challenges are about to get real, and this genius physicist is indeed the ultimate buzzkill when it comes to defying his laws. Get ready to pounce on some wild physics. Let's put a feisty 1-kilogram kitten in a rocket and see what happens when this little ball of fur hits the gas. As it zooms up to just 1/5 the speed of light, our kitty suddenly tips the scales at 20 grams more. Is it stress eating or something else entirely? But wait, things take a dramatic turn as our spacecraft approaches that magic 90% mark. At this point, Einstein's math shows our adorable kitten has now doubled in mass. Buckle up and let's dive into the mind-blowing world of relativity. Einstein revealed that as an object speeds up, it becomes more resistant to further acceleration. This is what we call relativistic mass. It all comes down to the massive amount of energy the kitten needs to keep pushing limits. The closer our little hero gets to light speed, the heavier and harder it becomes to keep going. And if we were to push that rocket to nearly break the light barrier, things get crazy. The kitty's mass would skyrocket towards infinity. The catch: building a rocket strong enough for a tiny passenger like this kitten is straight up impossible. You're probably thinking, if Einstein's theory of relativity says that speeding up makes you heavier, why doesn't the Flash just turn into a blob while zooming around? Well, let's introduce Lythak, our genius scientist superhero who defies the odds. Armed with knowledge of negative energy and its mind-boggling effects on mass, he's able to control his body's density in a way that perfectly balances out the weight gain. But here's the question: can Lythak's clever hack truly make him invincible? Or will other laws of physics come into play? Hold on to your seat. As Lythak nears light speed, time won't be moving at his pace anymore. Think of it like a super slow motion effect. But here's the coolest part: as he zooms by, the world around him will start to blur out, giving him that tunnel vision effect we've all seen in movies. Don't worry though, this isn't Lythak going blind, it's actually our physics at work. The faster he goes, the more distorted his view becomes. But trust me, our hero can handle it. But wait, there's more. If Lythak could somehow power past the ultimate speed limit, things would get seriously wild. Photons smacking into his eyes would be beyond what our human visual system can handle, essentially making him see way beyond what we're used to. And when he breaks through light speed, time would come to a standstill, but not for Lythak. He'd keep moving forward, leaving everything else frozen in place. But here's the question: if he could overcome this barrier, what would it mean for our hero? Would he be able to see and experience things that are literally beyond human perception? You might recall that Lythak has this incredible ability to balance his mind-boggling mass. But hold up, it's a delicate dance. If he even for a split second stops focusing on keeping his powers active while zooming past light speed, disaster would strike. His foot would crush the ground with an unimaginable force, annihilating everything in its path, including our home planet Earth. Picture this: the asteroid that wiped out the dinosaurs would seem like a tiny sniffle compared to the destruction we'd face. To save us all from certain doom, let's send Lythak on a journey through the emptiness of space, but now hold your breath, we're about to kick off a chain reaction that'll get the entire universe caught in the chaos. Get ready for a mind-bending twist. According to Einstein's theory, if Lythak keeps pushing past the speed of light, time itself would start unraveling, literally. When he breaks through this warp barrier, everything around him will suddenly go into reverse. Can you imagine? It's like rewinding reality. In a weird way, he might be able to sprint all the way back to Earth and catch up with his past self just as he starts the race. But here's the shocking part. It's unlikely our hero will live to see this paradox play out. You see, everything Lythak leaves behind, not just light, but also other particles that travel at incredible speeds, would now be coming back towards him at an unstoppable pace. Hold on, it gets even crazier. These high-speed particles aren't just light, they're also part of what keeps our world running. They're in every chemical reaction between atoms and molecules, happening at a blistering 300,000 kilometers per second. When Lythak zooms past light speed, he'll be moving so fast that he won't interact with any photons anymore. That means he'll become invisible to us, like a ghost blasting through space. But there's an even more intense consequence. By outrunning light and outsmarting these particles, Lythak will also break the bonds holding atoms together in his own body, essentially disassembling himself. But wait, it gets even wilder. If Lythak somehow manages to defy the odds and reach such incredible speeds, his body would either disintegrate into a cloud of dust or blow up with an explosive force equivalent to 100 atomic bombs. Can you imagine? But here's the thing: this super fast idea isn't just impractical, it's also impossible. And that's because Einstein's brilliant followers have cracked the code. They've figured out why breaking the speed of light only leads to chaos and not cool superpowers. You thought the speed of light was just a number, 300,000 km per second, but it's so much more than that. It's actually the ultimate speed limit of our entire universe. Nothing, not even the most mind-blowing energy or force, can go faster. And get this cosmic rule isn't just a suggestion, it's a law hardwired into the very fabric of existence. So, if we dared to defy it, well, let's just say the universe would have some major issues with that. In fact, it might even unleash a response that could wipe us all out. Talk about a cosmic reality check. Alright, speed demons, let's say you're still itching to go supernaturally fast. The Multiverse Fan Club would tell you, why not try another universe? Maybe over there, physics is like a totally different game and 300,000 kilometers per second is actually turtle pace. But hold up, because while the laws of physics might be upside down in that other reality, the harsh truth is this: if things work so differently, chances are you won't even make it past that first tick on your timer. In a place where everything is turned on its head, you'd probably not last longer than a second all. And that's being generous. This isn't an instruction to rewrite text, but rather appears to be a metadata label. If I were to continue from the previous response for context, alright, speed demons. Let's say you're still itching to go supernaturally fast. The Multiverse Fan Club would tell you, why not try another universe? Maybe over there, physics is like a totally different game and 300,000 km per second is actually turtle pace. But hold up, because while the laws of physics might